Hey everybody, this is the last section in chapter 6. We are looking at 6.6, which is properties of kites and trapezoids. The very first thing that I want to make sure that we are 100% aware of is that kites and trapezoids are not parallelograms. Okay, I repeat, trapezoids and kites are not parallelograms. So those parallelogram properties, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other, none of those apply today. Okay, I know we've been doing those for several sections, but today none of those properties work for these figures because they are not parallelograms. All right? So the first thing that we're going to look at is a kite, and a kite is a quadrilateral that has two pairs of consecutive sides congruent. So it's these two that are next to each other are congruent, and these two that are next to each other are congruent, but they're not the same this way. All right? So our first property of a kite is that my diagonals are perpendicular. Okay, so like a rhombus, my diagonals are perpendicular. All right, the next one is that if we have a kite, then one pair of opposite angles are congruent, and only one pair. Okay, so no more than one pair are congruent. And the pair of angles is going to be where your sides meet that are not the same. So like this is our single slash side, this is our double. Where they meet, that one is one of the opposite pairs that's congruent. Okay, A and C will not be congruent because again, that would be a parallelogram property. These are not parallelograms. All right. So what we want to look at is what else do we know about a kite? Even though they're not specific theorems, what else can we say is true? So what I'm going to do, and what I want you to do in that first picture, is I'm going to go ahead and draw this diagonal. All right? And then look and see what happens here. I know AC is congruent to itself. So I have the top triangle and a bottom triangle in my kite. So these two triangles are going to be congruent. So I can say triangle ABC is congruent to triangle ADC by side, side, side. Okay, so from that, I know all of my corresponding angles are congruent. Okay, I know this is congruent to this. I know this is congruent to this, and I know this is congruent to this. Okay, so because my triangles are congruent, I know that all those matching pairs of angles are congruent. I also see that diagonal AC bisects those angles because they are congruent on either side. So AC is bisecting angle A and angle C. Okay, BD will not bisect. Okay, it will not bisect angles B or D. All right, or angle B. Okay, that's actually written really weird. Or angle D. All right. Okay, let's look and see what else we know. Okay, I'm still going to draw in this diagonal, but I want you to, actually, let's start, hold on. I'm not going to draw that one in just yet. Let's start with this diagonal. Okay, I want to start here. So if I'm drawing in this diagonal, I want you to look at just the triangle over here. Okay, when we look at this, do you notice that this triangle here is isosceles? So remember, an isosceles triangle, my base angles are congruent. Well, if I block out this side, the same thing is going to be true. I have an isosceles triangle here, so my base angles here and here are going to be congruent. All right, so that's the first thing. Is I get an isosceles triangle, so these are congruent, isosceles triangle, so these are congruent. All right? Then we are going to look at drawing in the other diagonal now. Okay, remember one of our properties is that diagonals are perpendicular in a kite, so I know that this is a right angle. Well, look what's happening here. I know, and again, I'm kind of just going to ignore this side for a minute. I know there's a double over there, so I'm going to make this a triple. Okay, this piece here is congruent to itself, right? If we label this E. All right, AE is congruent to itself. So if I look here, I can say that triangle ABE is congruent to triangle ADE. Because look what we have. I know I have a right triangle, okay? The hypotenuses are congruent, and I've got a leg that's congruent. So by HL, my triangles are congruent. I can say the same thing for this other side here. All right. This is 1, 2, 3, 4. Okay. This is congruent. Again, these are perpendicular. So I can say triangle CBE is congruent to triangle CDE. Again, by HL. Okay. Since these are congruent, all right, and I have these two congruent, then I'm going to run out of lines here, guys. I'm just going to change colors, all right? I know that this piece, know that it's not the same as this, is going to be congruent to this. So that means that AC is bisecting BD. So BD gets bisected. This angle here gets bisected. Or this diagonal gets bisected. So one diagonal is bisected. AC is not. Okay, this length is going to be different than this length. Okay, so AC is not bisected. All right, so basically, we just went through a whole lot of stuff. Okay, what I want you to really take out of this, guys, is that in kites, you're going to get congruent triangles all over the place. All right. Most of the time when we're looking at a kite and we're using it in terms of trying to find a problem or an angle measure or a side length, whatever the case may be, when we're looking at kites, most of the time we are going to break it down into a triangle of some sort. Whether it is a big triangle like I have over here, and I'm just doing that whole top half, or I'm breaking it down into the little pieces where these are congruent and these are congruent. All right. But either way, I've got lots of triangles within a kite. Okay. And it's important that we recognize that, because that's how we will solve most of our problems, is more by using what we know about triangles rather than what we know about kites. So let's take a look here. All right. We are told that the measure of angle FEJ is 25 degrees. So FEJ. So this angle here is 25 degrees. We are told that FJG, so FJG, nope, can't read, FGJ, this way, FGJ, is 57 degrees. So this angle here is 57 degrees. Okay, I'll actually make this a little easier. I'm just going to draw the arrow. So this is 57 degrees. Okay, now I want to find each angle measure. Number one, before I do anything else, I know that these are right angles. All four of these are right angles. Okay, because remember, diagonals of a kite are perpendicular. That's the main thing we need to remember, because almost everything else will stem from that. And again, we can break things down into triangles. So what I want to look at is angle GFJ. So GFJ, this one right here. So basically, what I'm going to look at is I'm going to look at this triangle right here. And I know that in a triangle, they're going to add to 180. So the measure of angle GFJ is going to equal, I'm going to add, 57. I'm going to add 90. I'm going to set that equal to 180 degrees. Okay, so then I'm going to get the measure of angle GFJ plus 147. Whoops. 47 is equal to 180 degrees. And we're going to subtract that from both sides and get that the measure of angle GFJ is 33 degrees. Okay, so this one right here is 33 degrees. Now remember, this triangle is congruent to this one, so this angle right here is also 33 degrees. This one right here is also 57 degrees. Okay? All right, the next thing that we're going to look at is JFE. So JFE, that's this angle right here. So with that angle, I am going to be looking at this triangle right here. All right. So same thing here. I know that this is a 90-degree angle. So these triangle angles are going to add to 180. So I'm going to do that JFE plus 25 plus 90 is going to equal 180 degrees. All right, so the measure of angle JFE plus 115 is going to equal 180 degrees. So when I subtract 115 from both sides, I'm going to get that the measure of angle JFE is 65 degrees. So again, that's this angle here, so that's 65 degrees. Now, again, this triangle is congruent to this one, so I know that this angle here is also 25 degrees, and I know this angle here is also 65 degrees. All right, so the measure of angle GHE. All right, the measure of angle GHE is this whole angle right here. So the measure of angle GHE is going to be 65 plus 33. So the measure of angle GHE is 98 degrees. All right, so again, in a kite, a lot of what we're doing is, one, remembering that diagonals are perpendicular, and then breaking it down to its triangles. All right, if you have any questions, just make a note of it and then ask me tomorrow. All right, let's take a look now at trapezoids. All right, with trapezoids, okay, again, not a parallelogram, but I do have one pair of parallel sides. All right, so our definition of a trapezoid is a quadrilateral with one pair of parallel sides. All right, the other pair cannot be parallel. Those parallel sides are called our bases. The non-parallel sides are called our legs. All right, on either end of the base is base angles. So I'm looking at B and C are a pair of base angles. A and D are a pair of base angles. I know that means that every angle in the trapezoid is technically a base angle, but we look at them in terms of the pairs along the base rather than kind of individually. So these two go together as base angles. All right. When our legs are congruent, it is called an isosceles trapezoid. All right. One thing that I do want to make sure that we recognize here is that because these two sides are parallel, these two angles here and here are same side interior angles, so they are supplementary. So please make sure that we remember that. Okay, so the angles along the leg are going to be supplementary because they are same side interiors. All right, so let's take a look at some of our properties that happens. Now, the properties for just general trapezoids, again, you've got that one pair of sides are parallel, and those angles along the base are going to be supplementary. Now, isosceles trapezoids are going to have some extra properties. All right, so when we have an isosceles trapezoid, just like in an isosceles triangle, our base angles are going to be congruent. So if I'm looking at one of the parallel sides, the angles on either side are going to be the same. These angles are going to be the same. So let's just say for a second that I had that this angle was 100 degrees. All right, well, I would know that this one is 100 degrees because these have to be congruent. These are supplementary because they are same side interiors, so that would make both of these 80 degrees. If I add all four of these together, they are 360. All right. The next one is kind of the converse of that. So if I have a trapezoid and one pair of base angles is congruent, so like if I have just BC and AD are parallel and angle A and angle D are congruent, then I know that it is isosceles. Okay, so kind of like our isosceles triangle theorem. The theorem said, hey, if you have an isosceles triangle, your base angles are congruent. The converse said, if you have congruent base angles, then your triangle is isosceles. It's the same concept here. All right. So my concept here is, if I have an isosceles trapezoid, base angles are congruent. If base angles are congruent, my trapezoid is isosceles. So this one goes both ways, just like the isosceles triangle theorem did. The next piece of a trapezoid, when it is isosceles, is that it does have congruent diagonals. Okay, so just like a rectangle, it has congruent diagonals. But unlike a rectangle, it is not a parallelogram. Okay, so that's why it was so important when we were proving a rectangle or we were proving a rhombus, that we also proved that it was a parallelogram, because now you've seen two shapes today that have properties of a rectangle and have properties of a rhombus. So like a kite and a rhombus both have perpendicular diagonals, but a kite is not a parallelogram and a rhombus is. Okay, a rectangle and an isosceles trapezoid both have congruent diagonals, but again, a rectangle is a parallelogram and isosceles trapezoid is not. So that is why when we were going through those in earlier sections, we had to make sure that it was really important that we also showed parallelogram, because we have these same properties without a parallelogram this time. All right, so let's take a look at using some of this information. All right, I'm told that RT, so this whole diagonal here, is 24.1. Okay, I'm told QP is 9.6. I want to find PS. Well, remember that diagonals are congruent. All right, so I know that PT is going to equal QS. So the diagonals are going to be this. I wrote T. Q. Come on, erase. QS. Sorry. Okay, because my diagonals are congruent. So I know that QS is equal to QP plus PS. That is our segment addition postulate. Like, we're bringing that back all the way from chapter 1. So PT is 24.1. So that means that QS is also 24.1. QP is 9.6. All right, we subtract the 9.6 from both sides, and I get that 14.5 is the length of PS. So the big thing to remember is that these are the same length. So 24.1 minus 9.6 gives us that missing length. All right. So with this next one, we want to find the value of y so that this trapezoid is isosceles. All right. If our trapezoid is going to be isosceles, we want these base angles to be congruent. So I'm going to set 2y minus 25 equal, 2y squared, equal to y squared plus 24. So I'm going to subtract a y squared from both sides. So 2y squared minus y squared is 1y squared. Okay, then we are going to add 25 to both sides, and we're going to get y squared equals 49. And then we square root both sides, and we're going to get y is plus or minus 7. This is a perfect square. Now, because when we plug this in, there is no place that I have a y just by itself. Okay, plus or minus 7 actually works in this case because even if I plug in a negative 7 here, when I square it, it's going to become a positive 49. So it is important to realize that there are a few cases where we do need that plus or minus. Okay? The last thing that we're going to talk about for this whole chapter, actually, is a triangle midsegment. Not triangle midsegment, a trapezoid midsegment. Okay, so just like the midsegment of a triangle, it is going to be a segment that connects midpoints. The only key thing here is that with a trapezoid, it is just the midpoints of the legs. So in a trapezoid, we only have one midsegment, whereas in a triangle, we have 3. All right, so with this, okay, it's going to run parallel to the 2 parallel bases. All right, so all 3 of these are going to be parallel. Now, a triangle midsegment was half of that parallel side. Okay, a trapezoid midsegment is half of the sum. So basically what we're going to say, and you'll see it in your notes as well, is I can take 2 of these and 1 of each of these. And I'll show you here in a second. Okay, so if I take my 2 midsegments and kind of line those up, and then my 2 bases, and that one got a little crooked, so it's not quite correct. Let's straighten that up a little bit. Okay, they're going to be the same length. All right, I wasn't super perfect, so they are a little bit off here, but if you were to do it exactly, these would match up. All right, the other way that I like to write this is instead of doing this, is I like to do 2 times xy is equal to BC plus AD. This usually ends up being easier than dealing with the 1/2. All right. So this is in your notes. It's in the box kind of off to the side. But I do want you again to understand that this is usually easier than trying to deal with the 1/2. All right. So let's take a look at how this works. All right. So it's going to be 2 times my midsegment is equal to the sum of the bases. All right. I want to find ST here. So I'm going to label that as X. So I'm going to do 2 times my midsegment, which is 31, okay, is going to equal X plus 38. So 2 times 31 is 62. That's going to equal X plus 38. We're going to subtract 38 from both sides to get 24 is equal to X. So this is 24. Okay. Let's look at this one. So I've got 2 times my midsegment, so 2 times 2x plus 4 is going to equal the sum of my bases. So 2x minus 4 plus 3x plus 2. All right, distribute, we're going to get 4x plus 8 is going to equal 5x minus 2. Okay, subtract 4x from both sides. We're going to get 8 equals, x minus 2. Add 2, we get x is 10. I want the length of MN. So I'm going to plug this in. So it's going to be 2 times 10, which is 20, plus 4. So MN is 24. All right. So this is 24. All right, this is 2 times 10, so 20 minus 4, which is 16. 3 times 10 is 30, plus 2 is 32. Okay, one of the things that I want you guys to kind of notice in a midsegment, the difference between these numbers is 7. The difference between these numbers is 7. That is always going to be the case. All right, the difference here is 8. The difference here is 8. Your midsegment is going to be in the middle of those lengths of the bases every single time. So they'll always have the same difference. All right, so that's kind of something that you can use to kind of help you double check to make sure that you have done things correctly when you know they are spaced out evenly. Okay, so that is it for chapter 6. That wraps us up. If you guys have questions, let me know and I will be happy to answer them. I will see you guys later. Have a wonderful day.